10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello everyone. Hope you all are doing great and safe at your end. Welcome to the day 2 of pre-hackathon speaker sessions at Hack This Fall. At Hack This Fall, we will be hosting lots of live workshops, talks and discussions, and it has already been started from yesterday and will end on 30th of October. You can check out our website for a complete schedule and to know more about our speakers. Now coming on to the today's speaker session. It is going to give you an introduction about Tensorflow.JS, which is an open source JavaScript library that allows running machine learning models on the browser itself and helps integrate the models with web application. Using TF.JS in hackathons is particularly amazing because you get a quick machine learning model application for your project. So with that being said, let me introduce you all to our speaker of the session, Shivay Lamba. We have Shivay Lamba joining us today. Shivay is an open source enthusiast, Google Summer of Code mentor, MLH fellow, and Tensorflow.JS SIG, and community member, currently working at Darkhorse, a soccer analytics startup as a lead engineer. We welcome you, Shivay, and look forward to your talk. The virtual stage is all yours today.
Thank you, Tirthak, and again, a very big thank you for the entire team at Hack This Fall for making this event, and I'm really excited for even seeing all the kind of projects that people are going to be making, and hopefully after this session on Tensorflow.js, I would love to see that someone actually step forward and they introduce this topic. So probably if you want, we can start right now, or would you want to start within the next couple
Please
of minutes?
go ahead.
It
will be very great. Yeah, we can move on.
So without wasting any further time, I would love to get started. Again, big thanks to the entire team, and I'll be more than happy to take up questions after this talk. And just to sort of give a very brief overview, today we'll be talking about Tensorflow.js and how you can use that in your project at this hackathon or any other hackathon in general, or in projects in general. So we'll be going over what exactly is Tensorflow.js, how you can get started by looking at a few resources, what are the different types, and what is the power of using Tensorflow.js in your projects. And I'll be also sharing a brief demo on how you can quickly get started with it, and how you can use it at any event or for your personal project. And I'll be more than happy to take any questions that might come up at the end of the session. So I'm more than happy to get started. And again, a big thank you to the entire team at Hack This Fall for making this hackathon and this talk possible. So without wasting further time, again, like as Tirthak had already introduced myself, so I'm Shivay, and I'm currently a TensorFlow.js community working group member and community member representing India. And I'm currently leading the engineering team at Darkhorse, which is a football analytics company. And I've previously mentored at Google Summer of Code at Jenkins, and in Google Code in Mentorship, I've mentored in the TensorFlow organization. And I've also won a few hackathons, and I'm a Linux Open Source Summit recipient. So just a brief background on, okay, why exactly are hackathons important, right? So for a lot of you, it might be your first ever hackathon coming in for this Hack This Fall. A few of you might have already participated in a lot of different virtual hackathons or in-person hackathons earlier. So, but again, like just sort of giving a very brief rundown on what exactly is a hackathon. So a hackathon is a timed event, which is usually around 12, 24, 36, 48 hours event, where you're building a product. It can be a software, it could be a combination of software and a hardware, and you're trying to solve a particular problem, or your project sort of lies under a particular theme. Now, since it is a very timed event, and you're also at you're making this project from scratch, so a lot of times, for example, let's say a lot of times you're also learning new technologies at the same time. So a lot of times, what people might run to, like, the major issue, or the biggest sort of the worry thing that people sort of come up, is that they don't get enough time to actually implement things. So, like, that is something that has sort of come to me, as a lot of times people sort of self doubt themselves, that whether they will be able to sort of complete, or, like, let's say if they're getting started with new technologies, what are the ways in which they can optimize their time when it comes to a hackathon. So, like, let's say, for example, if you're a beginner, and let's say if you're even beginning with machine learning, right? So even then, you can actually look at a lot of different resources, and Tensorflow.js is definitely one of those resources about which I'll be sort of talking today. And again, don't worry, even if you are a beginner, this talk is geared for everyone. So, without wasting any time, sort of giving a brief on what exactly is ML, or machine learning, for those people who are new to the field. So, machine learning is a field, is a concept where we are basically empowering the machines or the computers to sort of take decisions based on certain patterns that they see in the data. So, normally, a normal computation of how it would be that you would be giving an input to the computer, and you would be giving the operation, and it would produce the output. So, like, let's take a simple example of a calculator application. But in machine learning, what happens is that, based on the output and the input, the machine itself is able to predict what is the operation that is going on. And once it has predicted that, you'll be giving it further set of input data, and based on the predictions that it makes, it will give a predicted output, right? So a lot of times, and again, like, machine learning is one of the biggest buzzwords today, specifically in the last few years, because now you're seeing machine learning applications in almost each and every different field, whether it's using data science, or machine learning applications in research, or in commercial applications, right? And so that is why, like, machine learning itself is a very big concept, and it does require, to a certain extent, a good amount of practice and knowledge of not just the programming aspect, but also of mathematics, statistics, if you really need to get good at machine learning. So a lot of students who might be in their first, second year, might have just started with machine learning, might not have the most clear concepts, and they might not have the requisite amount of knowledge to actually implement that in a hackathon project. And today, like, probably in the last few years, a lot of different hackathons have machine learning as a standalone theme that people can actually make projects on. And let's say you are coming in with very limited amount of experience, or no amount of experience in machine learning, and you want to get started, right? And you have experience with web development, right? So even then, using TensorFlow.js, you can get started without having any knowledge of how machine learning works, or how the machine learning algorithm works. And coming on to the third question, that is, what is the need of machine learning and web development? So machine learning, as I said, is being used everywhere, and web development, or basically web applications today, are the most consumed resource of sort of information or usage in terms of practicality, in specifically since now we have sort of gone virtual, even in the workspaces, and all the different events are going on virtually. So what you see are the web applications, or mobile applications, are the most used content on any kind of a technical platform. So that is why, and what you see is that like, web development itself is hugely popular amongst different people, right? And when it comes to web development, you're seeing actually the machine learning usage in almost all the different kinds of web development fields. So, for example, let's say it's a YouTube video, or Amazon as the e-commerce platform, where you're getting recommendations of products, or in case of YouTube, you're getting recommendations of videos. Or it's like Twitter, where Twitter is using sentiment analysis to sort of detect and delete any kind of hate posts or discriminatory posts happening online. Or it is Gmail, which is characterizing your emails on the basis of whether the email is spam, or it is a promotional email, or it is an important email. So you're seeing the applications of machine learning in all the different kind of fields. So the question that arises is that as a web developer, do I need to also learn, like, do I need to actually just go out and have a complete knowledge base, spend months actually training myself into using machine learning in case that is a requirement? So the answer is no. So that is where the concept of TensorFlow.js comes in. And before we speak about like what exactly is TensorFlow.js, just sort of a brief background on what is TensorFlow. So as I've talked about machine learning, a TensorFlow is an open source library that has been created by Google, and it is specifically made for having very large competitions. So normally what happens is that when you're working on a small project, the competitions, the mathematical competitions that you might be having might be limited. But when you're talking about large scale production grade products and projects, over there the competitions that are happening every second are in millions, billions, right? So that is why TensorFlow was made as an open source library that helps in basically computation, like in the computation of those either those applications or those research projects that might be going on. And they are particularly being used in the concept of neural networks, which is or the other alternative native for alternative name for it is a deep learning, and that is based on how the neurons in your brain work. So I'll not be going into much detail on what exactly is going on behind the scenes, based like keeping in mind the base of this particular talk. But yes, and just like a few facts about TensorFlow, that it is, again, as I've already said, that and is usually being used to run on very large computations, and it accepts data in forms of very high dimensional arrays. Again, not going too deep into how it internally functions. And basically how it actually functions is that it basically creates these data flow graphs, which is nothing but the flow of the information going on from one part of the system to another. So whenever any kind of a decision or machine learning application is used, how the flow of the information is happening. So that is like briefly describing how TensorFlow works in the backend. And now the thing that I've talked about is what is the need of TensorFlow.js. So again, just a brief background on TensorFlow.js, as Tat had already sort of said, that TensorFlow.js, like TensorFlow, is a completely open source library that has been created by Google, by the team working at TensorFlow at Google, and it provides you the ability to actually add machine learning models, whether those can be pre-built models or those can be customized yourself, to actually run them with your web applications, and to actually run them on the client side or on the server side, on any kind of a web application. Now, what's actually the biggest advantage of actually using TensorFlow.js is that this was specifically made for people who are creative designers, who have been into JavaScript programming for a long time. And for them, it can be very difficult to sort of switch to another language like Python to actually, learn, first of all, learn Python and then machine learning concepts. So for them, specifically for those hardcore JavaScript developers who didn't want to, switch to another language, or for those creative professionals who are just using web development, or these creative designers who are not really concerned about the programming aspect, but they are using web development as a means of showcasing their work. So specifically for those people, so that those people who don't have any knowledge or have very limited amount of knowledge can directly start using machine learning models. Because even before TensorFlow.js came in, as I've already said, that these platforms like Twitter, Facebook, Amazon, all of these are actually using web development, like they're actually using machine learning in web development. But usually how that process actually worked was that you used to create a Python based machine learning model, then you used to export it and actually upload that on a server, and then connect that as an endpoint or as an API, and then run it with your web development application. But again, the question is that since those people who might not be having knowledge of machine learning or Python, how we could actually circumvent that problem. So that is why what we're trying to say is that machine learning today is being used in almost all different fields in JavaScript. And JavaScript itself is a very, very versatile language. And as you can see from the slide, that the JavaScript itself can run on browsers, it can run on servers. So an example for that is Node.js. It can run on desktop applications, it can run on mobiles, it can run on IoT based applications. And these are like just a few of the examples. So on browsers, it has support for all the different browsers that are out there, like Chrome, Firefox. It can run on the server as a backend language using Node.js. It can run on mobile using React Native, which is again based on JavaScript. It can run on desktop. We can create desktop-based applications using Electron.js. We can use Raspberry Pi to create IoT-enabled applications or products. And since JavaScript itself is so versatile, having a technology like TensorFlow.js introduces machine learning in all of these different fields or all of these different devices, and makes it compatible with all of them, and making it huge, like largely scalable as a product and as a service. So that is why TensorFlow.js makes it highly usable and highly easy for introducing the concepts of TensorFlow or machine learning without any much knowledge of those fields. And now coming on to how you can actually leverage the use of TensorFlow.js. So again, it's very easy, and there are basically three main categories of how you can actually use TensorFlow.js with your machine learning applications. So the three main distinctions are that in case you're coming in with absolutely no knowledge of machine learning, you can directly use some of the existing models that have been provided by the TensorFlow team. Now, to sort of run down on a few of them, like a few examples, you can actually go to the TensorFlow GitHub account, which I'll be just showing you briefly on how you can access these models. And these models provide you easy to use functions. So you simply just have to import these functions directly to your web application, and you just have to use the functions as they are. So it's simply as simple as a plug and play operation, where you can run these already existing models that have been created, and you can directly just use them without any further training. So there's a concept in machine learning called training, where the machine learning or like the computer itself first extracts the feature of the input data set to sort of understand what are the different features, what are the different sets of information that it can get from the input data, and then it is able to sort of come up with those predictions based on once it has understood the features of the training data. So you don't have to do any kind of training. You can directly just go ahead and use these models as they are. Now, this is one category. The other category is retraining existing models. So this is what we call as transfer learning. So what happens in transfer learning is that you would be provided with some existing machine learning models that you can actually train your data on, so that it sort of embeds itself, or it is able to understand, and it sort of becomes more adaptive to your particular input data. So let's say in case you don't know how to train data, you have the basic knowledge of machine learning on how the machine learning pipeline actually works. So in that scenario, you can actually use transfer learning, where you don't have to create your own model from scratch, but you can use the pre-existing models and then train them over your input data that you have for your own data sets, and try to improve the accuracy and the adaptability of those algorithms to further suit your scenario, like whatever use case that you might be having. So that makes it extremely easy to actually use these applications, and you can use the transfer learning application to actually get started with the retraining of the existing models. And in case you don't know, in case you want to write your own models from scratch, you have a good amount of knowledge on how machine learning models work, so you can actually write your own models directly in JavaScript. So I'll be coming on to how you can actually get started with that. So this is the most higher amount of use case that you can have, that you can actually write complete models from scratch. You don't need to use already existing models, and that is the amount of flexibility that TensorFlow.js actually provides for you to actually use machine learning within JavaScript. And you can, since as I've already said that JavaScript itself and web development are so popular, you can actually create any kind of an application, like let's say augmented reality, virtual reality, gesture-based applications, accessibility, sentiment analysis, like on Twitter. You can have custom bots that you normally see on chat, like for example, custom chat bots. So all of these different kind of applications that you see on web can actually incorporate the use of TensorFlow.js within themselves to actually improve upon the experience by providing machine learning in your web application. And now coming on to what I said about the first type of experience, so that is using pre-built models. So TensorFlow.js actually provides you the ability to actually go through different kinds of data models or like machine learning models that are already present, and you can directly just use them or import them and directly use their functions to actually make some predictions or use them in your applications. So you can actually go to tensorflow.org/js /models, which have a few of the models like image classification, which classifies between different types of images, object detection, body segmentation, pose estimation. And just to sort of give you a brief background on how you can get started, I'll be sharing my screen again. So you simply have to go to github.com/tensorflow/tensorflow.js, and you can actually go. So I'll just sort of give you an example. So again, as I've already said, that GitHub is an open source platform where all the different open source projects are there. And I've already said that TensorFlow itself is a completely open source platform. So as you can see, TF.JS is completely open sourced, and similarly TensorFlow itself. And what you will see over here are the TensorFlow models. So TF.JS models, if I just quickly type that in. So these are all the different models that I'm already saying that these are the pre-trained models that you can directly use in your application. So let's say if I want to have a look at MobileNet, you can see that if I go to the README, it will show that you simply import these dependencies, and then you simply load and you run the classify function. Or for example, if it's like any other function that you can actually use. So that is, like it makes it as simple as just using the output function of these models, right? So that is why the TensorFlow.js pre-existing models are so super simple and super easy to actually use. And coming on to the next part, I've already said that object recognition using the Coco SSD model is a very popular object recognition model that has been created in Python, but now it has been ported over in TF.JS, and it has over 90 different classes that you can actually predict or you can recognize using a Coco SSD model, and this is just increasing in terms of the number. And now coming on to the second part, that is the second scenario that I talked about, which is the transfer learning. So over here you're using the existing models, but you're sort of making them adapt to your own data. And a very good example on how you can actually get started with like these this transfer learning is teachable machine. So a teachable machine is a service provided by Google, which sort of runs deep learning networks, neural networks in the background. And you can actually provide your own input data to it, and it will train itself on your input data and provide you recommendations. And then you can actually directly just export those models and you can use them. So currently what you can see is, so example, let's say I get started with this, right? And what you will see are a few of the categories. So you can run like an image project where you're using image recognition. You could do something like a pose project where you are actually determining what kind of pose are you, like standing up, are you sitting, or you can have something like an audio project, and more are being worked upon. So let's say for this demo, I'll be creating an image project. So what's happening is that these different classes that you see, so basically in machine learning, the different classes, what they mean is that there are different types of data. So for example, let's say you're making a machine learning project that recognizes the difference between dogs and cats. So one class would be dogs, and all the different dogs will be having certain set of features that are similar to each other. So within all the different input that you have within one class will have similar features, and similarly for the other class. So again, it's as simple as like opening your webcam, and then for example, let's say I want to distinguish between my mouse and my phone. So I'll quickly, what you have to do is enable the webcam and record as many number of images. So again, just to keep in mind, the more number of images that you train, the higher accuracy, because the more number of data that your machine learning model has, the better it is able to actually extract the features. But given like the time for this hackathon speaker session, I'll be just training a few images, like let's say around 20-25. And the more number of images that you have, the more training time it will actually take. So let's say I introduce my phone and I hold to record. And so let's say if I have 30 images, I guess this should be fine. And let's say the next class, and I name this class as mobile, and the second class is mouse, right? And I'll open my webcam again, and I will train my model to recognize the mouse, and I'll be training again exactly 30 images, right? So I'm done, and now you can actually train your model. So what's happening is that it is actually create, so whatever machine learning model that it is actually using in the backend, and the machine learning model itself is a deep learning neural network, which I'll just sort of show you how it is actually doing. So what's happening is that it is actually now going through these two different classes and now extracting the features, as I've already said, using this deep learning neural network, and it is now training. And very soon, very quickly, you will be able to actually see. So as you can see, now if I want to get started, let me bring my, so all what you can see is the output. It will distinguish between whether the input is a mobile or a mouse. So let's say if I bring my mobile, you can see that it is actually showing 100% prediction. So what's happening is that once the machine learning model has been created, it sort of now provides you a prediction on the new incoming object or like incoming data. So for example, if I bring in my mouse, you can see that it gives you 100% accuracy in terms of giving it as classifying it as a mouse, right? And now the beauty of actually, this is that you can now export this model. So, and you can actually export it directly with let's say JavaScript if you're using. So let's say if you wanted to make a hackathon project that distinguishes between different types of garbage, right? So let's say you're making a garbage detection system, it can distinguish between whether a particular image is of garbage or not. So you can just quickly make this model without having any knowledge about that, and you can actually directly just export it, and it provides you documentation on how you can actually use the different functions. And the best part is that I've already said that if you want to actually go into depth, if you have knowledge about, let's say, deep learning, you can sort of change a few of the settings like epochs, batch size. Again, not going too deep into the neural networks. These are various parameters that you can sort of set while training your neural networks to sort of change how the different weights perform. And again, like if I want to show you what's happening under the hood, so these are like this gives you a much more sort of in-depth analysis of how the training is actually taking place. So this is the concept of a teachable machine. Again, it's a very exciting concept if you want to like use one of these existing models and train it on based on your application and directly just export it and use it with your web application. So that sort of like tells us about the transfer learning aspect. And cloud AutoML is basically, for example, what I showed right now is it does have like a limitation of, let's say, training up to 1,000 2,000 images. But let's say if you have 100,000 plus images and you want to train them, or you have to create a like a production grade machine learning model, you can actually use cloud AutoML, which actually provides you the ability to train image based models in huge quantities, so it can easily scale up to, let's say, 100,000 images at the same time to actually train them and deploy them. And now coming into finally, that is Tensorflow.JS, writing your own code. So this gives you the most amount of flexibility because it allows you to write your own custom machine learning code or machine learning model directly in JavaScript. And to sort of support that, to support people who are creating their own models, it basically provides you two different kinds of APIs. So one is a high level layers API and the other is the low level ops API. Now, what's the difference between them? So as a standard TensorFlow, like if we just talk about TensorFlow, TensorFlow itself is a very low level language or low level library. So what does that mean is that it will actually provide you the ability to, let's say, write your own custom mathematics to further improve your machine learning model, and it allows you to have complete granular control over whatever model that you're writing. But to assist those people who might not want to go into that much amount of deep depth into creating, like writing their own mathematics, they can actually use a high level library that has been created on top of TensorFlow called Keras. And Keras provides you some inbuilt functions that you can directly use to sort of circumvent and to help in your project. But similarly to TensorFlow and Keras, TensorFlow.JS also provides you a low-level ops API, which provides you control of actually changing your mathematical functions, mathematical models, and it also provides you some high-level APIs, which is called the layers API, like Keras, where you don't get so much in-depth control over like the inner working of the machine of the mathematics, but you still have complete granular control to actually write your own models. So this sort of will give you sort of a better idea of what how all the things are working. So at the top that you see are the models. These are the pre-built models that you see, which I've already discussed about. Then you see the layers API, which is based on like Keras, that provides you the ability to write your own custom code. And finally, you have the core or the ops API, which is the low level API, which provides you the ability to write your own custom code. Now, it actually, you can, whatever code that you're writing, the machine learning TensorFlow.js based models that you're writing, you can actually run them on the client side and on the server side. So when it comes to the client side, you can actually run the machine learning models directly on the browser itself. So this is something that I forgot to introduce earlier, that tensor, like the machine learning itself can be computationally quite heavy. But with the growing advent of the browsers, and as more and more people are taking interest in web applications, the browser itself has a certain amount of RAM and certain amount of processing power that it can actually use to actually render these machine learning models, right? So you can actually run these machine learning models directly on the web browser itself, which supports things like WebGL, which is using like web-based graphics acceleration happening directly on the browser. Or in case you have a very big model that requires a lot of computational power, then you can actually run your model directly on the server, which is using the Node.js server. And there's also something known as the TF.JS converter, which is basically used to convert Python-based machine learning models into JavaScript. And again, TF.JS converter is completely open source. It uses C++ bindings, and again, internally to actually convert a Python-based model into a JavaScript model. So that sort of should give you a brief brief overview of what we have discussed so far. And what I want to also show over here is that in terms of the performance as compared to a standard machine learning TensorFlow model that runs on a Python background, you see that like the performance itself is not too different from the standard machine learning applications that I've been running on graphics cards, or let's say on these standard platforms. So what you can see is like the models performance are very close, because again Node.js itself is quite powerful, because it uses just-in-time compiler at its runtime, and that provides you much more quicker inference of the models and faster processing. And now coming on to sort of, as we sort of close down on the introduction to TensorFlow.js, the five sort of, like a few like a few sort of great things about why you can actually use the TensorFlow.js on the client side. So the first is the privacy. So why is this important? Is that because normally what happens is that, for example, let's say you're creating a backend model. So you're hosting your backend somewhere on a, let's say on a public cloud, or you're using a public cloud service, right? So normally all your data that sort of flows, it's actually going to that database or to that server. And in case you're having some kind of important information, in that scenario, you might, it becomes susceptible to attacks in between when the data is actually transferring from the browser itself to the server. So it since everything is now running directly on the cloud, it's running directly on the browser itself. So the data that stays, it's actually staying locally within your browser or within your laptop. And it also provides you lower latency because since I've already said that everything is running directly on your system, on your browser, so there's no data like server connectivity. So all the models, all the results that come in are very quick. You're saving server cost, so that is why it's less costly. And again, since it's like, easily available locally, it is quite scalable. But in terms of, let's say, you are having a very heavy model, in those cases you cannot use the front end or like the client side. In that, you are actually running them on a dedicated server. And you can also use like the TensorFlow saved models, which have been written directly in the JavaScript, and use them directly. And then as I've already said, that you're using the just-in-time compiler of Node.js. And also, since Node.js has these Node package modules, so you have a very huge support of npm modules that you can actually use to sort of help out with your application. And again, to sort of go through a few of the models, you can actually go to tensorflow.org/js, which is like, you can find more information on how the tensorflow.js is actually working. You can find a few tutorials in case you want a few demos that are there. So this gives you a very great sort of overview on how you can get started, and think about a few ideas that you could probably utilize to make your projects. And you can go through the github.com/tensorflow/tfjs that I've already showed you. And in case like you have any questions that you might be coming in, like for example, when you're working, you can go through the tfjs@tensorflow.org Google group, where people are regularly asking questions. Now, before moving on to sort of finishing with the talk, I created a very small sort of a demo application. First, I would like to give you sort of a demo on how it is actually working, and then I'll also show you like how it is super easy to get started, working with a TensorFlow.js model, and using that to actually help you create a very simple and fast applications that actually have machine learning within them. So I'll quickly open my VS Code, and I have created this application, a very simple application. And so I'll quickly, start running this. So I created this very quick application, and it literally took me just half an hour. So this like just like I've created this demo application for Hack This Fall, and it is basically a mood detector. So I showed you in the teachable machine that I distinguished between a mobile and a mouse. So in this, I'd be making a few happy faces and a few sad faces, and based on, once like you have trained the model, based on your expression, it will actually change the background of the web app. So let's start. So basically, as you can see over here, I have my webcam open. So it is taking the input, whatever input is taking, it's taking each frame of the input that you see on the webcam. So let's say I first start by training the happy faces. So I'll get started. So I'll make a happy face, and I'll click to actually train it. And what you can also do is that you can sort of shift around a bit, so that it can take multiple angles, and it is able to understand or extract features better. So let's say I take in around 20 images, and I can now make some like a neutral face or a sad face. Okay, I'm good to go. And now we click on train, and it will take some time. Again, it is using a mobile net model, which is used for image classification, right? So let's say now it has trained. If I make a happy face, it should change the background. as you can see, like if I have a happy background, it shows the image of this mountain. And let's say if I have a sad face, so you can see that it shows this raining image. And if I again make a happy face, it goes back to this mountain. So basically, as you saw that it was like a super simple demo, and I'll also just sort of go through the code. So I've created this very simple index.html that has so I've also imported p5.js and ml5.js. Just to sort of give you a brief background on ml5.js. So for those people who might find a bit difficult to actually understand TensorFlow.js itself, which has actually made it super simple to use, machine learning. And so that is why ML5 is sort of, even a sort of a layer further, or like a step further of simplifying TensorFlow.js. And it has been specifically made for, artists or creative coders or students who are coming in with literally no information or knowledge of TensorFlow.js or machine learning, and it provides super easy to run applications and functions that you can use. So what I've done is I've imported ml5.js, and as you can see over here, I'm sort of taking my canvas. So you find this canvas that I'm already using. So what you can see is that we have created these three buttons that are the happy, the sad, and the train buttons. These have been sort of mapped to a JavaScript function that you actually uses them once you click them. So these are functions with particular applications. And then what you can do is that now quickly just going over to the sketch.js, that is sort of the main brain behind the entire application that we have created. So as I've already said that using ml5.js, we have imported MobileNet. So MobileNet is again a very popular machine learning model that has been used for image detection, image classification, and again, it's very popular. And in case you would want to actually go through and go through the actual algorithm itself and the code, it is actually quite hard to understand at first for people who might just get started. So ml5.js, TensorFlow.js sort of takes over that difficulty for you, and you simply just have to use its function without really knowing what is going on in the background. So we import MobileNet. What you see over here is that we are sort of getting all of these different documents. So basically, using document.getElements by ID or by tag name, you're able to get your HTML tags or your HTML components and use them in your JavaScript. So the first thing that you see over here is so we'll first talk about the function setup. So what you see over here is creating a canvas. So the canvas that you saw over on the lower left corner, so basically that is the canvas where we are now inputting our video frame. So that is where the webcam is getting access, and it is now capturing the video stream. So how does it actually take place is that the video stream comes in as an input, and each frame of that particular video is taken as a new input, right? And over here, as you can see that using ML5, we are using the MobileNet model, and we are importing the MobileNet model directly. And the classifier, since we are classifying between different type of images, we are calling in the MobileNet.classification model and the video. So the video stream that is being used, it is being used as the input over here. So that is why you see the video, which is the input to this machine learning model. So the next thing that you see over here is we are basically using now the buttons. So we had the sad button, we had the happy button, right? So using the sad button, what we're doing is we are counting the number of input data that we are actually giving to, let's say, the sad or to the happy. So for example, in the sad, the more number of clicks that you see, as you saw, that the more number of images that it will actually train. So we are actually adding we have created these two different classes. One is the sad class, one is the happy class. So more number of sad images that we select, it will add those many number of images to the sad class. And if you're adding them to the happy class, it will keep adding to the happy class. And once we are done with that, we click on the train button. What you see over here is classify.train. So this will actually now take in both the input classes, both the sad class, the happy class, fetch the features that are happening in both of them, and then classify. Ultimately it will classify. And once the training has been done, what you see over here is the got results function that has been created, right? And what you see over here is that once the results have been, so now what happens is that once you have done the complete training, your webcam is still continuing, right? So now that is the testing data, right? Or the test data. And now you will actually find like results, because now the machine learning model has got to know, okay, these are the two specific classes, the sad class and the happy class, and now it will be able to actually predict whether the next frame that comes into the webcam, is it belonging to the sad class or to the happy class. So let's say if now I use the classify.classify, which based on the got results. So these results are again the new input stream from your webcam. So in case, let's say if it is classifying the new result as sad, it will, what I've done is that I have changed the background image of the project to actually have, let's say, a sad image, which is actually the image of rain. And in case, like, let's say if it's happy, then it will change it will change the background image to something called, like, for example, to the mountains that I showed you. And again, like, this is just a very simple example. So literally, you didn't have to go through what exactly is mobile net, what is like what is happening behind mobile net. And if I want to actually show you the mobile net mathematics, right, so you would actually see that what kind of complexities are usually going behind when it comes to the mobile net, right? So this is like transfer learning using mobile net. And what you see over here is, like, the internal structure of how it actually takes place. So I'm just showing you an example. So, like, this is how it actually works, right? So just to sort of give you example as this loads up. So as you can see, like, since it's based on neural networks, it is quite complex to understand. But you don't need to actually know any of that. You're simply just using two or three basic functions that are dot train, dot classify, and dot predict. So those are the only things that you're using, and everything is being handled by the ml5.js model itself. So that is why it makes it super simple to actually use these models. And this should give you like a brief background on how we were using it. And sort of that brings us to an end. As I promised that I won't be taking more than 50 minutes, you can connect with me on these links. And I'm also a mentor at Hack This Fall. So in case anyone would want to have any questions regarding how to get started with TF.JS, in case you had an idea in mind regarding like using machine learning as one of the technologies in your project, and you'd want to try to use TF.JS, I would love to take over any queries with respect to the resources, or in case you're running into any difficulty. So, and again, you can connect with me on these platforms. And again, to connect with me in case you want to learn, or you want to any how reach out for any help with regards to either open source development or with web development machine learning. So you can follow me on Twitter at how develop, LinkedIn, and on GitHub. And I'd be uploading this code that I've created for this demo after this meeting, and I'll be sharing it in the speaker in the speaker Discord channel. So in case anyone wants to have a look on how you can import or get like sort of a starter code, I'll be uploading this demo code that I've used in this talk. Now I would be more than happy to take up the questions. Let me quickly just share my screen again.
Hello everyone. So please do ask question. It's a great thing to interact with Shivay, because he has an experience of being a hacker himself in various hackathons. He is an MLH fellow. He could help you out in some other thing. So would request if there is any question. So I think in the chat section there are few. Okay.
Okay.
If there are 10 to 15 classes, how much accurate is teachable machine?
Wow, that's a really good question. So again, like when it comes to the teachable machine themselves, the basic functionality of what it wanted to do was that it is. So again, like first let's say what's happening behind the scenes in teachable machine. So it's using a neural network, right? So even in the scenario that you have, let's say 15 or 20 different classes, and you have enough data to actually include in each of these different classes. So let's say you're having 300 different images for 15 different kinds of classes. Then like it can still be accurate because it is using a very good optimized neural network in the background. And in case you know how to further optimize any kind of a neural network, and you want to see how that training is actually going on, you can actually go and adjust, like let's say the number of epochs, or let's say the batch size of your training model. So it gives you that much amount of flexibility. But yes, in terms of as compared to, let's say, if you had to create your own model from scratch, you could definitely get more amount of accuracy by, let's say, going through different kinds of neural networks, trying to see, okay, how many layers do you want in your neural networks. But then that is going to too much technical depth. In case, and again, in case you have that kind of a knowledge, you might better use it and try to compare it with a teachable machine. But teachable machine itself will give you quite highly accurate results, because again, as I said, that it has been made keeping in mind ease of use for people who might not be having knowledge base of TensorFlow.JS. And like as Google has created it, it has a certain degree of good accuracy. So even if, like, let's say you're having 20-25 different classes, it should be good enough, given that you have a requisite amount of input data that you're giving to it. And in case, like, you would want to further improve the accuracy, I've already said, you can tinker around with some of the settings, like the number of epochs.
Great. So it was an amazing answer. So the next question appears: any project ideas which we can work on during the hackathon?
Okay.
Amazing.
Yeah.
Direct पूछना चाहिए.
Oh, that's a good question, Jay. So again, like, first of all, like, so I'll just sort of give you my breakdown on how I come up with these project ideas. So probably the most easiest way is to look at the different themes that have been provided in the hackathon, and look at which one of these might be the most useful for you, like which one are you able to actually connect with, and sort of using a top down approach. So first you see what are the different themes, and then going over each theme and just thinking about a few ideas that you could probably work on that particular theme. Or the other is that, in case you have any idea that sort of comes to your mind, that somehow is able to solve a problem of the society, or let's say it is solving a particular issue with, let's say, related to the coronavirus pandemic, or so just sort of thinking about a few of the issues that are going around you, that are going on in the world, and then coming up with ideas related to that. Or you can always still reach out to mentors to sort of further validate your ideas, because that is why the mentors are there in the first place. Because a lot of times when you're starting out new, you might find it difficult to sort of sort of formalize one final idea that you might want to work on. So that is why connecting with other people, sort of sharing your idea with them, so that you can sort of fine tune and get more in-depth aspect on whether it's actually fruitful. But generally, in case you think your idea stands out, you can just definitely work around. But normally, in case you'd want to sort of self-explore, just think about things around you that you feel can get improved by the use of technology. And in case you feel that you're confident enough that it is going to take, like, it will help out, then I'm more than I'm more than confident that it will actually be successful, and you'll make a great project.
Amazing. I hope Jay would have got the okay. So how excited you are for Hack This Fall?
100%. I'm more than happy, like more than excited to be actually seeing the amount of students and mentoring. And again, it would be probably a great thing to actually see if someone comes in and makes these models using TensorFlow.js. Because again, a lot of people a lot of students usually start with web development, and they might not really find a lot of machine learning developers. And since I've already said that machine learning itself is being used in almost every field right now. In case you want to use, as I've already showed in a few of the demos, it is super easy to actually incorporate within any kind of an application. And it's not just actually limited to the TensorFlow, like to the web development applications. TensorFlow has a wide variety of different projects. So you have a TensorFlow Lite that can run on mobile applications. You have TensorFlow that runs on that runs on these Raspberry Pis, right? So that is why it's super easy to actually incorporate in multiple different scenarios, not just like related to web development.
Amazing. Thank you very much for answering all the questions, Shivay. It was amazing interacting with you. And just one thing from my end. So,
Yeah.
is there anything which you would like to suggest to our hackers at Hack This Fall through your experiences, with hackathons? As whatever I know about you, you have participated in hackathons even as a mentor or a speaker. I'd like
Yeah.
to know that what you can suggest to our hackers.
Absolutely. So again, first of all, the most basic thing is keep it simple and enjoy yourself. Because hackathon is in itself. I so For some people, yes, it's a competitive event where you're competing for the prizes. But personally, whenever I go to hackathon, I always go with the spirit of learning. So always be curious and eager to learn, because you'd be learning something new, whether it's let's say learning a new technology, learning how to use a new API, right? And a new API, or let's say you're learning something from the other fellow hackers, right? Because you're getting such a diverse set of developers coming in to participate in that hackathon. So always have that curiosity levels up, and always just concentrate on what you're building and trying to see whether it is actually able to solve a particular problem. So in case if you have that clarity in mind, then you will be able to make great progress in the hackathon, and just continue to just sort of enjoy yourself and take in as much amount of knowledge that you can actually take in from that experience, right? Because you're not just building a product, you're having experience of working in a team, you're pitching your project. So it's not just about the development. So keeping in mind on all of that, the only sort of the advice that I want to give is interact as much as possible with all the fellow developers, the mentors. Ask your questions, ask your doubts, because everyone usually is very super friendly and more than willing to guide you, and learn new technologies. As you're having all of these different speaker sessions, you're learning new and new technologies like Flutter, TensorFlow. You're having all of these different workshops, so learn from that and try to implement that in your projects. And again, don't feel dejected if you don't win, because in case even if you end up losing, you still have a myriad number of opportunities when it comes to hackathons, because more than 10-15 hackathons take place every week, right? So you'll still have more amount of knowledge, and whatever you learn from this experience at a hackathon, just go forward and use it further. So let's say if in case you want to continue building upon your project that you couldn't complete at a hackathon, go ahead and just complete it or work on newer technologies. So like that is my sort of my mentorship or my viewpoint on how to actually get the most out of a hackathon.
Still very fantastic thoughts. I must say, I was searching for a Sandeep Maheshwari for hackathon. I got one. Amazing. Thanks a lot, Shivai, for the talk. The presentation was really very amazing. But yeah, I would like to say that some hackers might not be able to join this session live, but
Yeah,
they will surely ask questions in the Discord channel. So as and when you get time, please look out at the Discord channel and do answer them. So it will be
absolutely.
a great environment there. So thank you very much again for joining
Thank you.
us.
Thank you again.
So, guys, do fill out the feedback form shared in the chat section, and it will also be used to assign certificate for this session. It will be only open for next 15 minutes and won't be reopened again. So don't forget to fill that out. Thanks a lot, everyone who joined us today. Don't forget to subscribe this channel so that you can get the updates for the workshop coming up ahead. Stay tuned. Hope to see you in the next session. Stay safe and take care.